Ever wonder who revolutionized abstract algebra? Meet Emmy Noether. Born on the 23rd of March, 1882, in the quaint town of Erlangen, Bavaria, Germany, Emmy Noether was destined for greatness. The eldest of 4 children, she was surrounded by an atmosphere of intellect and aspiration, thanks to her distinguished father, Max Noether, a respected mathematician and professor at Erlangen. Her mother, Ida Amalia Kaufmann, hailed from an affluent family in Cologne, adding a touch of wealth and sophistication to their lineage. Emmy's 3 younger brothers each carved their unique paths. Alfred Noether, a chemist, was awarded a doctorate from Erlangen in 1909. Fritz Noether became an applied mathematician, while Gustav Robert Noether, plagued by ill health, lived a life far removed from the academic pursuits of his siblings. The Noether family wasn't always known by that name. They were of Jewish origin and had to adopt a Germanic name due to the Tolerance Edict of 1809 in the state of Baden. The family's original patriarch, Elias Samuel, chose the surname Noether, later anglicized to Noether. This adoption of a new identity marked a significant chapter in the family's history, laying the groundwork for the legacy that Emmy Noether would go on to create. Emmy's childhood was undoubtedly influenced by her family's intellectual and cultural background, yet it was the convergence of her intrinsic curiosity, passion for learning, and the nurturing environment that truly sparked her genius. She was an ordinary girl with an extraordinary mind, a clever, friendly, and likable child who, despite her slight lisp, stood out for her participation in Jewish religious classes. In these humble beginnings, no one could have predicted the profound impact Emmy Noether would have on the world of mathematics. For Emmy Noether, the journey to greatness began with education. This journey took root in the quaint town of Erlangen, Bavaria, where Emmy's educational journey started at a school nestled on Fahrstrasse. Despite her nearsightedness and an unassuming demeanor, Emmy was a clever, friendly, and likable child. Even her slight lisp could not hide the spark of intelligence that shone brightly within her. From the school on Fahrstrasse, Emmy transitioned to the Städtische Höhere Töchterschule on Friedrichstrasse. It was during her time here, from 1889 to 1897, that the seeds of Emmy's mathematical prowess began to sprout. The school, known for its rigorous curriculum, provided the fertile ground for Emmy's intellectual curiosity to grow and flourish. Emmy's high school years also saw a significant change in her personal life. In the middle of her high school journey, around 1892, the Noether family shifted to a larger apartment at Nürnberger Strasse 32. This move, while seemingly mundane, signaled the beginning of a new chapter in Emmy's life. As her environment expanded, so did her world of knowledge. It was during these formative years that Emmy's passion for mathematics began to take shape. She was not just a student absorbing information, she was a young scholar, actively engaging with mathematical concepts, constantly challenging and pushing her understanding to new heights. Emmy's high school education was not just about learning what was in the textbooks. It was about discovering her love for mathematics, a love that would define her life's work. Emmy's early educational journey was a testament to the power of a nurturing environment in shaping a young mind. The schools she attended, the teachers she learned from, and the challenges she overcame all played a crucial role in molding Emmy into the mathematical genius she would become. As Emmy matured, so did her passion and talent for mathematics. These early years were just the beginning. Emmy Noether was on her way to etching her name in the annals of mathematical history. Emmy Noether didn't merely study mathematics, she transformed it. A statement that captures not just her genius, but also her tenacity and pioneering spirit. While women in the late 19th and early 20th centuries were often denied the opportunity to pursue higher education, Emmy Noether defied these norms. She enrolled at the University of Erlangen, a place that had a special place in her heart, not only because her father was a distinguished professor there, but because it was a beacon of knowledge, a place where her mind could wander unencumbered. Her initial studies were in the languages and the classics, but she soon found herself drawn towards the allure of mathematics, a field that her father, Max Noether, had made significant contributions to. In her thirst for knowledge, she audited courses, as women were not allowed to officially enroll in mathematics, but her brilliance could not be contained. She completed her dissertation in 1907, marking the transition from a student to a professional mathematician. Emmy's contributions to the field of abstract algebra were groundbreaking. She introduced innovative concepts and methods that would forever change the way we understand and apply mathematics. One of her most significant contributions was her study of chain conditions on ideals of rings. This concept, now known as Noetherian rings, has become a cornerstone of modern algebra, influencing numerous areas of mathematics and theoretical physics. But her accomplishments were not limited to her research. She was also deeply committed to teaching, sharing her knowledge and passion with the next generation of mathematicians. Despite the challenges she faced, Emmy Noether proved that intelligence, determination, and a love for one's craft can overcome even the tallest barriers. Emmy Noether was not just a mathematician, she was a pioneer, a woman who broke through the glass ceiling of her time, transforming not just the field of mathematics, but also the way we view women in science. Emmy Noether, a name and legacy that continues to inspire mathematicians and scientists around the world. Emmy Noether's work continues to resonate in the world of mathematics. As we delve into the impact and legacy of Emmy's work, we find a realm that transcends time and space. Even today, her contributions to abstract algebra, particularly her study of chain conditions on ideals of rings, form the bedrock of many modern mathematical theories. The genius of Emmy Noether was not just in her ability to solve complex mathematical problems, but also in her capacity to see beyond the immediate. She understood the inherent interconnectedness of mathematical principles, a perspective that allowed her to make groundbreaking strides in her field. Her work is not only admired, but also foundational, underscoring the complexity of mathematical structures and systems that we encounter today. Notwithstanding her monumental contributions to mathematics, Emmy's journey was not without its share of struggles. She was a woman in a field dominated by men, a persistent pioneer who broke through the barriers of her time. Her tenacity and unyielding spirit, coupled with her undeniable genius, have made her a symbol of resilience and inspiration for countless mathematicians and researchers. On the 14th of April, 1935, Emmy Noether passed away in Bryn Mawr, Pennsylvania, USA. Yet her demise did not mark the end of her influence. Rather, it amplified the reach of her work as her theories continued to be studied, analyzed, and built upon. Her ideas have been passed down through generations of mathematicians, her name etched into the annals of mathematical history. The world lost a brilliant mind that day, but Emmy's legacy is far from lost. It lives on, vibrant and influential, in the theories she developed, the problems she solved, and the minds she inspired. Her work continues to shape the field of mathematics, proving that the true impact of a genius is not measured by their lifespan, but by the enduring resonance of their ideas. Emmy Noether may have left us, but her mathematical legacy is eternal. Emmy Noether's life was a testament to the power of perseverance and intellect. Born in the late 19th century in Erlangen, Bavaria, Germany, she navigated the tumultuous tides of her time, rising above societal norms and expectations to etch her name in the annals of mathematical history. Her father, Max Noether, a distinguished mathematician himself, no doubt played a crucial role in shaping Emmy's early interest in the world of numbers and equations. Emmy's journey into the realm of academics was not a straightforward one. She faced numerous hurdles, not least of which was the prevailing bias against women in academia. Yet she persisted, proving herself through her work and gaining recognition for her formidable intellect. She ventured into the esoteric world of abstract algebra, making significant contributions that would forever shape this field of study. Emmy's work on chain conditions, on ideals of rings, stands as a testament to her brilliance. It is through her tireless efforts that we have a deeper understanding of these complex mathematical concepts today. Her work paved the way for future mathematicians, breaking down barriers and pushing the boundaries of what was deemed possible. The resilience and determination shown by Emmy Noether throughout her life serve as an inspiration to all. Despite the numerous challenges she faced, from societal prejudices to personal hardships, she never let these deter her from pursuing her passion for mathematics. Her life reminds us of the power of the human spirit to overcome adversity and achieve greatness. In the grand tapestry of mathematical history, Emmy Noether's thread shines brightly, illuminating the path for future generations of mathematicians. Her legacy is one of revolution and evolution, a testament to the power of perseverance and intellectual curiosity. Her name is synonymous with abstract algebra, her work serving as a beacon of inspiration for all who delve into this complex field. Emmy Noether, a name, a legacy, a revolution in abstract algebra.